Everyone, myself Basudev Patra. Currently, I pursuing BTech EC from Lovely Professional University. So, this is my first presentation for power stabilization module for microcontroller protection. So, microcontroller are the brain of the many electronic device, but they are also sensitive to voltage fluctuation. Spikes, brown touch, and noise can cause uh, malfunctions or even permanent damage. To ensure reliable operation, a power stabilization module is crucial. This presentation will explore the key component and design consideration for such a module, aiming to provide a stable voltage supply deposit this variation. So my first point is voltage fluctuation, a real world problem. So first is automotive. In automotive application, microcontroller face harsh conditions such as load, dumps, and cold cranking, where voltage can dip as low as 6 volt. This fluctuation can lead to data corruption and system reset. Second is industrial. Industrial environment present challenge like motor starts and line voltage variation, often exceeding plus by minus 10%. Such variation can cause hardware damage and unreliable operation. Third is portable device. Portable device suffer from battery discharge and switching power supply noise. Consider the ESP32, which requires 3.3 volt plus minus voltage percent 10%. Uh, Voltage outside this range can trigger unexpected resist. So my second point is key component of power stabilization module. So first is input protection. A transistor voltage suppressor TVS diode is essential for protecting against voltage spikes and surges. Second is voltage regulation. A linear voltage regulation or DC to DC converter is used to maintain a stable output voltage. Third is filtering. Capacitor, bracket, bulk, and ceramic are used to filter out noise and stabilize the voltage. This is filtering. And fourth is monitoring. A voltage supervisor or reset IC monitor uh, the output voltage and reset the microcontroller if it is falls below a threshold. Fourth is transition voltage supervisor TVS for input protection. Input protection, yeah, not output, it is input protection. Purpose, the TVS diode clamps voltage spikes to safe levels, preventing damage to downstream component. And second is characteristic. Key characteristics included breakdown voltage, clamping voltage, and surge voltage. A SMJ508 TVS diode, for example, has a breakdown voltage of 6.4 volt, clamping voltage is 9.2 volt, and surge current is 400 watt. Okay, and third is selection. Selection of TBS diode based on maximum input voltage, expected surge levels, and response time. It should be placed as close as possible to the input connector. So my fourth is voltage regulation, linear regulator as DC to DC converter. So first is linear regulator, simple low noise but inefficient at high V in V output. Differential efficiency equal to V out by V in into 100%. Examples include LM7805 and LM317. So second is DC to DC converter, high efficiency, lower than 80%, typical, wider input range but more complex and noisy. Example include buck and push boost converter. So third is trade-offs. Consider cost, size, efficiency, noise, and input voltage range. The TPS5430 DC to DC converter, for example, has a 3.5 volt to 28 volt input and up to 3 ampere output. So my fifth is filtering capacitor for noise reduction. So first is bulk capacitor, a large electrolytic capacitor, example 100 mF you do it 100 mA, the establish the input voltage and reduce ripple. Second is ceramic capacitor, small high frequency capacitor. Example 0.1 mA, filter high output high frequency noise. They should have low equivalent series resistance for better performance. Third is placement. Place capacitor close the regulators input and output pins for optimal filtering. Use both a 100 mA electrolytic and a 0.1 mA ceramic capacitor. So 6 is monitoring voltage supervisor reset IC. First is purpose. The voltage supervisor reset IC monitor the output voltage and reset the microcontroller if it is falls below a specified threshold. This prevents the microcontroller from running with corrupted data. Second is feature. Key feature included an adjustable threshold, reset delay time, and active low, active high output. A max 810L reset IC, for example, has a threshold voltage of 4.63 volt and a reset delay of 140 ms. Third is prevention. By ensuring a clean reset, the supervisor IC prevents the microcontroller from operating with encrypted data and unstable clock signal, enhancing system stability. So my seventh is implementation example Arduino protection. So first is component modules, second is module, third is wiring, and fourth is testing. So an Arduino board vulnerable of voltage variation on the V-in pin. Use a TVS diode and an LM7805 linear regulator, 100 m and 100 mF and 0.1 mF capacitor and a max 10 reset IC. Connect the module input and external power supply. The output to the Arduino 5 volt and ground pins, and they reset the pin the Arduino reset pin apply. Varying input voltage and observe stable 5 volt output the reset functionality. Testing and validation. First is load regulation, second is line regulation, third is transistance response. Perform load regulation test by measuring output voltage change with varying load current. Conduct line regulation test by measuring output voltage change with varying input voltage. Evaluate transient response by measuring output voltage overshoot understood during sudden load changes. Environmental testing should include temperature, humidity, and vibration. Success criteria include an output voltage within plus minus 2%, minimal overshoot undershoot, and reliable set functionally. So my ninth is conclusion. Ensuring reliable microcontroller operation. A power stabilization module is essential for robust microcontroller application, protecting against voltage spikes, brownouts, and noise. The key component are a TVS diode, voltage regulator, capacitor, and a reset IC. Careful selection and implementation ensure reliable performance and prevent damage. By implementing these techniques, developer can significantly enhance and reliability for a longevity of microcontroller based system is diverse and demanding environmental. Thank you.